You'll have noticed that from time to time we've mentioned SIP transactions. Well, in this module we'll formally define and recap what we know about the SIP transaction, identifying each transaction in a SIP call. As we've said, the simple rule for a transaction is that it begins with a request, often ends with a final response that concludes the transaction, with an exception, and includes any provisional responses that might be in between. Another rule that we've not discussed yet is a transaction is only ever over one hop. Now, we've not discussed it before because until now we've only looked at peer-to-peer calls, none of which have traversed more than a single hop. In the next chapter, though, we'll look at calls routed via multiple servers over multiple hops between caller and callee. A SIP transaction is only ever over one hop. So, in a successful call, the first transaction begins with the invite request, ends with the final response, the 200 OK, and includes the 100 trying and the 180 ringing. In a peer-to-peer call, all these messages traverse only a single hop between the caller and the callee. In a proxied call, however, the invite and its responses traverse multiple hops. Remember, a transaction is only ever over one hop, meaning these messages here and these here can't belong to the same transaction. They belong to different transactions. When sifting through the logs and troubleshooting problems, particularly server logs where there's many SIP messages from many calls, it's important to be able to identify and group messages from the same transaction. Now, do you remember the rule, the key to identifying transactions? It's the branch parameter on the topmost via header and the CSEC method. All requests and all responses in a SIP transaction have the same branch parameter in the topmost via header as well as the same CSEC method. Now, so far we've only ever seen one via header in each of our SIP messages. Watch this space. In the next chapter we'll see growing lists of via headers as a request is proxied downstream, each with their own unique branch parameters. More on that later. So it's a common branch parameter on the topmost via header and a common CSEC method that's key to identifying messages in a transaction. So transactions typically begin with a request and end with a final response, but with one exception, and that's the ACK. The ACK after a 200 type success response to an invite. The ACK following a 200 success response is a self-contained transaction with no final or provisional responses. Beware of the ACK, it likes to break the rules. More on the ACK later. Following the invite transaction, the ACK transaction is the second transaction in a successful call. The third is the buy transaction. It begins with the buy request, ends with the 200 OK final response, and includes any provisional responses in between, if there are any. And just like all other transactions, the buy transaction is only ever over one hop between two adjacent entities. Note how both messages of this transaction have the same branch parameter and the same CSEC method. That's the key to identifying transactions. It's a different combination from the invite transaction that began the call, different branch parameter and different CSEC method type. In a failed call, however, things are different. All of the messages including the ACK are included in the same transaction. Now, the reason for this is not obvious in a peer-to-peer call. It will be later after we've discussed forking in the next chapter. So for now, just remember that in a failed call, the ACK is not a self-contained transaction like it was with a success scenario, but it's included in the failed invite transaction. Okay, in summary then, in a success call scenario, a SIP transaction begins with a request, ends with a final response, and includes any provisional responses in between, except for the ACK, which in a successful call is a self-contained transaction with neither final nor provisional responses. In a failed call, however, the transaction begins with a request, includes all responses, and this time also includes the ACK. When reading logs, we can identify the messages in a transaction through a common branch parameter on the topmost via header and the csec method. Remember, a transaction is only ever over one hop. Messages proxied downstream, although part of the same call, form different transactions.